I'll talk today about testing serverless application, and I'll try to tell you a story. Meet Alex. Alex is just another web developer like most of us. He's doing some Node.js, JavaScript, and many other things. He did PHP and many other things in his career. He's working in a small team building some cool things. And of course, he has some friends. His friends always talk about serverless in the past couple of months. And after some time, it became kind of boring for him to listen to those stories all the time. And what's even that serverless thing? Of course, no one told you that today, so I'll tell you again. When you're writing your application, you need some kind of server. And most of the time, it's a cloud server because you don't want to have a physical server. But you need more things such as operating system and some kind of platform or a framework and libraries that are installed on your server. And then you can put your application on top of that. And then users start using it, and more users, and more users, and even more, and more, and more. But at some point, your server just crashed, and your business is burning because you need a larger server or something like that. And then what you need to do is to pay some smart people to try to figure out how to make your application work. And they'll check some metrics and many other things, and they'll figure out that you need to scale your server, of course. But with scaling your server, you're also scaling your budget, because everything costs more, and maybe you're running just a small application or something like that. And serverless is basically a new way of how we can deploy our application and develop our application. Instead of just buying server, we push that to some platform, and this is not a logo of Half-Life, but it looks like that. And when it's even more cool because you're not paying anything unless someone uses your application. And then if more people are using your application, everything will scale magically, and of course you'll pay for all those requests. And of course, Alex had a really important question. Why is it called serverless? Because there are servers somewhere. And I love to quote my friend Gojko Adžić. He said that serverless is serverless in the same way Wi-Fi is wireless. Whenever you make requests from using your phone or something like that, your request will hit some wire somewhere, but you don't care about those wires. If they break, someone else will manage them. It's the same way how serverless work. And Alex kind of liked that. So when he had a new project that he was working with his team, he had a great idea to try out that serverless thing and try to fit his application inside that. And presented that to his team. Some guys on the team were against that. Most of them were neutral, and some of them were for that. Can you hear me? Yeah. And they decided to try it out. But where do you start? How do you fit? Because most of us have some kind of common development process that we are doing when we are developing our applications. So where do you start with serverless, and how do you fit serverless application in that process? So they had a simple process. So let's say that they wanted to develop some feature. First, they checked if that feature has some complex logic or not. If it's not complex, they start with writing the code. They run everything locally, and when that works, they write some tests. Of course, they iterate that many times. If the feature is more complex, then they start with some tests and then write some code, write more tests, run everything locally, and do things like that. When they have some feature that is working, they push that to some Git repository or something like that, and then their continuous integration and deployment tool deploys that to some development server or test server. Then QA team will test that, and then finally application will go to production. So they decided to just try to fit serverless application in this flow. They started with writing some code, and they hit the first roadblock. And the first roadblock was how to run serverless application locally. But before I explain that, I want to introduce one more person to this story, and that's Slobodan. That's me. So I'm Slobodan Stojanovic. I'm CTO of Cloud Horizon and also Vacation Tracker. As Matt said, I wrote a book called Serverless Applications with Node.js with my friend Alexander Simovic. It's a book that helps you to learn serverless basically from scratch using JavaScript and AWS Lambda. And I'm also AWS Serverless Hero, and you can follow me on Twitter, and from time to time I'm writing on serverless.pub website about serverless and things like that. So let's get back to our story. How do we run our serverless applications locally? Can we even do that? Well, we can. There are some tools that can help us to do that. For example, if you're using Azure, I think we saw that today, basically you can run that through now Visual Studio Code and many other things. If you're using AWS SAM CLI, you can run your function locally. If you can use some third-party tools like Local Stack and many other things. And you can even use Docker container to run something that looks like a serverless function that simulates the environment and everything. Or if you're just writing Node.js or some other programming language, you can just run that manually in your command line and test that your function really works. And of course, there are more and more tools, and we'll see even more tools because serverless is expanding really fast. But you can run functions, and often functions are just a small part of our serverless applications. And also, what about, for example, security or maybe some permissions and things like that? If you run your function locally, you'll never know if you have enough permissions, or if you want to use something like Cognito or Kinesis or whatever. It's really hard to simulate those things locally. And you basically can't run everything locally. You can run some parts of your application and develop faster by testing if your simple applications work, simple function work or something like that. But in the end, you probably need some to deploy the application to some kind of environment. And it's good that environments are relatively easy to set up now, because you can deploy with one command and things like that. And they're really cheap, because if you build a new environment for your developer or QA or someone else, you'll not pay for that unless they're really using that. And if they're just using that for development, most of the time your cost will be $0, which is great. Well, can we do better and make sure that our application really works before we push everything somewhere to the cloud? Well, yes, we can write tests. And Alex and his team hit the second roadblock, and that's how do you test serverless function? Well, let's talk about automated testing. Why do we need to test serverless applications? Isn't that managed by like your provider, like AWS or Microsoft or Google, IBM, and others? Well, they will make sure that your application scales and that your infrastructure works, but they don't have to do anything with your business logic. You still need to make sure that your application really works as you wanted it to work. So you still need to test those things. Well, when you want to test something, the first step is, most of the time, to find the tool that you'll use. And as Alex is writing mostly Node.js, he's using Node.js tools, and he was interested to learn if he can use some of those tools. And basically, he can. You can use any tool that you're already using to test serverless application. For example, if you're a Node.js developer, you can use Jasmine or Mocha or Jest or basically anything else that you are already using for non-serverless applications. Well, what should you test in your serverless application? Because that's another really important question. You don't want to test really everything. There's a thing called testing pyramid. It's introduced by Mike Cohn in his book, Succeeding with Agile. And it looks something like this. I added this thing on top. So he kind of tried to show what things you should test in your application by showing how fast are those tests and how cheap or expensive are they. And of course, unit tests are testing just some small unit in isolation, and they're really cheap because you don't need to spin up the database and things like that to run them. And they're really fast because, again, you don't need to spin up the database to be able to run them. So it's smart to have a lot of unit tests. And then he said that you should have a bit less integration tests because they are slower, but because you need to spin up the database if you want to make sure that your integration between services is working or some other service and things like that. And it's fast, and it's more expensive because, again, you need to do some things that you will pay for. Finally, UI tests or some end-to-end tests are most expensive because you need to deploy the full environment of your application, and then you often need to run the browser that will automate clicks everywhere and make sure that your application works, and that's really expensive and slow because often you need to wait. It's almost like someone is clicking that. And finally, if you have manual session-based testing, that's, of course, the slowest and most expensive part because someone needs to really clicking on those links, but it's smart to have that. Well, let's see how does that pyramid looks with serverless. Well, it's not really a pyramid, or maybe it is like Mayan pyramid or something like that. So unit tests are still cheap and fast. There's nothing special there. But integration tests are like important, and they're faster because you can run the other services easily because you can deploy them faster. For example, if you need another instance of your database, it's easy to just spin up that. And they're cheaper because serverless is quite cheap. And if you want to run UI tests or some other kind of end-to-end tests, it's again faster because we'll see later what we can do, but at least we can spin up another instance of our application easily. And it's cheaper again because the cost of serverless applications. Manual testing is still the same. It's because you need people, but I'll show you later, you can help your QA team to test your application easier with serverless. Well, the most important thing here are integration tests. They're cheaper and faster, but also really, really important with serverless apps because often your application is not just a monolith application that has everything bundled together. You often have small pieces everywhere. For example, something triggers one Lambda function, and that Lambda function will save some file, and then another Lambda function will be triggered, and things like that. And you really need to make sure that all those things in integration really works together, and if something fails, it shouldn't just crash your application and do things like that. So another thing that Alex and his team thought about is how to write a testable function. Well, there are many ways to just write testable functions, but they tried to see what risks do they have with like serverless applications. And they identified 4 different risks. First one is configuration risk. So do you have the right permissions for your function, for example, to access the database? Are you accessing the right database and things like that? Then you have technical workflow risks. Are you parsing the event as you should and things like that? Then you have business logic risks. Is your code working in a way that it should work? And finally, you have some integration risks. If your service, you need to make sure that your service will work with other services. And again, you can write a function in many different ways to kind of think about all those risks and handle those risks. But I love to use a thing called hexagonal architecture or ports and adapters. Its creator, Alistair Coburn, explained that as a hexagonal architecture allows your application to be equally driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. This seems like something that works really perfectly with serverless because you often can't run things locally, but if you can run this in isolation of its eventual runtime, that's really good. And if you can run your application or your function with automated tests and maybe the programs, that can be really, really good too. And it's called ports and adapters because it works almost like this. So for example, when I travel from Belgrade to UK, I can't just plug my computer into a wall. Instead, I have a small adapter that allows me to reuse my cable and just put that adapter on top of it and everything will work. So the point is that we want our application to work the same way. And let's see how does that work. So let's say that we want to write a function that will just get some API request and then store some data in the database, and finally send some notification via Slack or something. Instead of just bundling everything to one function, we'll keep our function, core of our function, like business logic inside, and we'll have 3 different ports. First port will be event port, which will expect some event that will come from different sources. And that event, of course, needs to be in a certain format. Then we have storage or database port. And finally, we have notification port. If I want to run this function locally, I can simply do some kind of local trigger, maybe invoke that function from a Node.js console or something like that. I can save my data in in-memory database, which is kind of adapter for that storage port. And I can trigger some local function that will just send a JavaScript event just to be able to test everything. But in production, I'll have another trigger adapter for API gateway, for example. Then I can have a different adapter for AWS DynamoDB or maybe Mongo or some other database, which again will talk to our port. And finally, I'll have some Slack or AWS SNS adapter that will be triggered through my notification port. And I'll show you later how does that work with another example. So let's go quickly through all those 3 phases of testing. So we have unit tests. And unit tests for serverless application are basically the same as unit tests for any other application. You're testing small units, like one function or things like that. Most of the time, you want to fully cover them with tests because you have just a few lines of code and things like that. And finally, you have those adapters that you want to mock. For example, you can pass those local events and things like that, or you can fully mock them. But integration tests are more important, and I said that many times, but I need to continue repeating that because they are really, really important. And you can use hexagonal architecture to help you out, to test those things with integrations. You need, of course, to be smart and to be sure that you're testing integrations that you own and that you actually use different adapters for integrations that you don't own. For example, if you want to run 100 tests to check your payment system or something like that, you don't want to invoke every time you run integration tests, you don't want to hit Stripe or something like that. Instead, you can have a different adapter that works similarly to Stripe and Stripe API and make sure that your application will talk to Stripe in a way that it should. So let's see another example. Let's say that we have a function that stores some files to S3. Often, I split my function in 2 important files. First one is lambda.js, which is really, really simple file. It doesn't need to be lambda.js. It can be, I don't know, Azure.js or something else. It works basically the same way for any operator, for any provider, and even for applications that are not serverless. So the first file will simply var all the dependencies and invoke the next file, which is our business logic, which is called main.js, for example. And that main.js will have its own unit tests and, of course, integration tests. But we don't want to test our main.js against S3 because maybe there are 10 other parts of your application using the same thing to store some things on S3. Instead, we want to test that main.js with another adapter, for example, in-memory file storage or something like that. And then we have file repository, which is a completely separate library that has its own tests, but also its own integration tests. And it's really important for that file repository to be tested against AWS S3 because we want to make sure that it really works in integration with that service. And that's it for integration tests. For UI testing, of course, we can spin up our application faster, but why do we even need to talk about UI testing? Because serverless is mostly backend thing. It doesn't have to, what does it have to do with front end and with like UI testing anyway? Well, UI tests are slow and expensive because you need to wait for it to click on everything and you need to have your application ready for tests and everything. But the benefits of serverless are cheap infrastructure and easy and fast parallelization. So maybe we can combine those 2 things and do something like this. For example, you can start your UI test, but instead of just starting some traditional tool that will run one test after another, you can probably split that into some batches that can run in parallel. And then you can do some crazy thing, for example, like putting your Chrome inside AWS Lambda, or using Google functions. I think they already have Chrome inside. So why would you do that? Well, there are things like Puppeteer and things like that that can just spin up the real browser inside your function, and you can just run tests there. And then it's much cheaper because you pay just a few cents for all those Lambdas, and you don't pay anything if you don't run your tests. And you can run many tests in parallel. You can even use Lambda layers now to just write your code and use the layer for Puppeteer or something like that. There are tools like, I mentioned that, Puppeteer, or even tools like Appraise.qa and many other tools that you can use to run your UI tests inside AWS Lambda. And some of them even work with some other platforms. So Alex and his team managed to write some functions that were working, and they finally wanted to test that. So they wanted to know how to deploy that with CI and CD tools. And let's talk quickly about CI and CD with serverless applications. Well, it works basically the same as any other application. You can use any of the tools that, that you're already using to deploy serverless application. For example, you can use Jenkins or maybe Travis or Semaphore CI. Or if you're using AWS, there's Code Pipeline with Code Build and Code Deploy and many others. Well, it's probably smarter if your deployment process requires broad permissions. For example, on AWS, you often need to, if you're using CloudFormation and SAM, you often need to give that give SAM like a lot of permissions to do many things with your account. It's probably smarter to use the CI/CD tool that your provider is providing, because then you don't need to share your keys with some other services. Not that I don't trust all those services, but I don't trust myself that I will not fuck up something and share my keys with where I shouldn't. And things that we are doing, for example, with our product, Vacation Tracker, is that we automate deployment from different Git branches to different stages. For example, dev staging and QA. Of course, production has some kind of gatekeeping in front of it. And that helped us to have really fast deployment cycles. And then Alex and his team managed to deploy their first serverless application to their test server. So it was time for manual QA session. And how does serverless affect that? Probably there's no big benefits, but let's think about that. So as I said, stages and deployments are cheap and often really fast to set up, much faster than they were before. And you don't pay for infrastructure that no one is using. So technically, you can have as many environments as you want. For example, each of your QA persons can have their own environments, or maybe each feature can have some environment, and you can tear them down afterwards and things like that. So you can help them by just deploying another production-like environment really fast, and they can do whatever they want, and then you can just deploy that to production. There's also another thing that you can use, at least with AWS Lambda. Basically, you can test a function, and then you can promote the same tested function without redeployment to production by just changing the alias of that function. So for example, you can label your deployment version 22 as testing or something like that, and then you can use it from testing environment, and then you can, when they approve that release, you can just change the alias for that version, and it can go to production. So the same code that someone really tested will go to production. Of course, integration will be different because production might have some different environment variables and things like that. There's one more thing. So Jan talked about about cost optimization and things like that. So each flow of your function costs differently. So we have many tools that are trying to optimize and to show us how much our serverless application costs. So At some point, your QA team will be able to notice if your flow is twice more expensive or something like that and point that out to you. So you can know that with the last update or something like that, you just created something that is running slower and costing more. And well, Alex and his team managed to deploy their first application to production, and they live happily ever after, right? Well, until someday, where a lot of angry customers were sending us support tickets because applications stopped working. Well, even in Wonderland, some things are not perfect, and you have some risks and challenges. Let's quickly go through the risks in serverless application. First one is deployment risk. So units are smaller and easier to test, but deployments and triggers and permissions are not trivial. And of course, they're getting easier, but it's hard to set up everything and to be sure that you didn't forget anything. So you should probably use some mature and well-tested deployment tool. And some of the popular tools are serverless framework, Claudia.js, which I'm one of the team members of, AWS SAM, Architect, and many more. And the other really important risk is integration errors and changes. Even if your application just works, after some time, for example, you integrated with Google Drive API or something like that, and Google then changed something, or whoever, maybe Facebook changed something with their chatbot API, your application starts failing. So how do you make sure that that doesn't happen? Well, you can't. You need some kind of monitoring and error tracking. And fortunately, there are more and more error tracking tools that can help you to catch those errors fast. And you can use things that are built into your platform, like CloudWatch, X-Ray for AWS. Or you can use one of the cool tools that exist now. For example, Lumigo is one that is here at the conference, or Epsagon, IOPipe, Tundra, and many others. Oops, sorry. Sorry for that. But often your applications are not just, with serverless, you shift many things to your front end. So you really need to make sure that you track front end errors as well. And you can do that with many tools like Sentry and things like that. But we also tried to create a small open source application that is fully serverless and that you can deploy to your AWS account. That's called Désolé. And it basically tracks errors in your browser. Well, with that, Alex and his team were happy. And Alex became one of the serverless crew. And he's just talking about serverless every day now. So let's go through a quick summary, because I think I have 2 more minutes or less. You can run and test some parts of your serverless application locally, but not everything. Automated tests are important, but you need to be smart. What are you testing? I'm using hexagonal architecture to stay flexible and to make sure that I can just grow my application and to test it well against all the integrations. You can use CI/CD tools to test and deploy, for example, different stages to different stages of your application, and you can use tools that you're already using. Your QA team can test the same function that can be deployed later to production, and you should definitely use mature and tested deployment tools and track your errors. And finally, serverless can help testers to do their job faster and cheaper, and developers should help them out with tooling and everything. Well, here are a few tools that I mentioned. I'll share my presentation later, but I have some code examples of the things that I've worked, that I showed with like images. If you want to see how hexagonal architecture works with code, I'll share my presentation, and then you'll be able to read this article. Claudia.js is our deployment tool, and Désolé is the application that I showed for front-end error tracking. And this is a tool that we're building with serverless. It's not really related to this talk, but we're using hexagonal architecture to test that in isolation with Slack and everything. Well, that's it. The last thing is, oops, my book. If you want to learn how to write serverless application with Node.js, you can read this book, and you can get it with some promo code, or after this, we'll have some promo codes that Matt will give out, and you can follow me on Twitter. Thank you. That's it.